Good evening, dear students. So let me discuss about the atomic models. I am Ashok Master. So my YouTube channel is Ask Physical Science. So you should try to, if possible. So please share my videos, like my videos, s- subscribe my videos. Okay. So let us discuss about the Bohr's model of hydrogen atom. So actually, the electron in an atom occupies stationary orbits different distances from the nucleus. Actually, here K shell is present. So the name of the first shell is K, name of the second shell is L, name of the third shell is M, name of the fourth shell is N. So these are the shells. Especially these shells are the stationary shells. What is mean by stationary shells or orbit? The electron in an atom occupies stationary orbits, so different distances from the nucleus. Mean the electron in the first shell or second shell do not absorb the energy, do not emit the energy. So that's why these shells are called a stationary orbit. So the shell which is closer to the nucleus, it has certain energy, that is E1. Second shell has certain amount of energy, that is E2, E3 and E4. Third shell E3, fourth shell E4. So the electron in an atom uh, occupies stationary orbits. These stationary orbits have certain energies, that are E1, E2, E3, E4. The electron jump from lower energy state to higher energy state. It absorbs the energy because of higher energy states. That's why, so for existence, it absorbs the energy. The electron jump from higher energy state to lower energy state. It emits the energy because of this is higher and ground state. That's why it emitting the energy. So, but the Bohrs explained about some properties of hydrogen atomic model, some postulates in Bohr's model of hydrogen atom. But some limitations also there. What are the limitations? So this hydrogen spectrum observed through the high resolution spectroscope so appears finer lines, but Bohr's could not explain about fine spectrum, that is also called Zeeman effect. This is the limitation of Bohr's model of hydrogen atom. So let us discuss about the second atomic model. So that is Bohr's Sommerfeld model. Actually, the Sommerfeld explained a fine spectrum of hydrogen atom. So according to Bohr Sommerfeld model, the Sommerfeld took first circular orbits of Bohr. This is n is equal to 1. He took the first circular orbit. So elliptical, he could not added any elliptical orbital to the first circular orbits of Bohr. So elliptical orbital denoted by the L is equal to 0, means he could not added any elliptical orbital to the first circular orbits of Bohr. So he took second circular orbit. This is second circular orbit from the Bohr's model. So he added one elliptical orbital. N is equal to 2 means here second circular orbit he could not added. He added one elliptical orbital. So n is equal to mean 2 L values. So L is equal to 0. He could not add any elliptical orbital to the first circular orbits of Bohr. So and L is equal to 1 means he added one elliptical orbital to the second circular orbits of Bohr. So third circular orbit he took, Sommerfeld took third circular orbit. He added two elliptical orbital to the third circular orbits of Bohr. So he could not, n is equal to 3 L values, means L is equal to 0, could not added any elliptical orbital. He added one elliptical orbital to the second circular orbits of Bohr. He added two elliptical orbital to the third circular orbits of Bohr. So next, fourth circular orbit he took from the Bohr's atomic model. He added three elliptical orbitals to the third circular, fourth circular orbits of Bohr. N is equal to 4 mean 4 L values. L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3. So this is about the Bohrs-Sommerfeld model. But one drawback in the Bohrs-Sommerfeld model, it could not explain the fine spectrum of more than one electrons of atom. He explained only fine spectrum of hydrogen atom. Bohr-Sommerfeld model could not explain fine spectrum of more than one electron of hydrogen atom. This is about Bohr-Sommerfeld model. So let us discuss about the quantum mechanical model. So uh, actually the electron revolving around the nucleus definite path means that is the circular orbits according to Bohr's model. So the electron revolving around the nucleus in circular paths mean what is velocity of electron, what is the position of electron. Arises two questions, what are they, what is velocity of electron. So we could not find the velocity of electron, and at the same time we could not find the position of electron. So maximum we can find we know about the position of electron, but not in all situations. Sometimes we can find the position of electrons, but we can't find exact position of electron. So that's why, because of electron is very smallest particle, we can't see with our eyes also, that is a very smallest. If we use the microscope also we can't see. So by using high resolution spectroscope also we can't observe. So by using the electron to observe the electrons using lower wavelength of light, but we can't see the electron, we can't find the position of electron because of the electron interacts with the lower wavelength of light. That's why we can't find. So that's why the Erwin Schrödinger, instead of orbits, he introduced orbital. So what is mean by orbital? The region space around the nucleus where the finding probability of electron is maximum. So it is called orbital. So the finding probability of electron is maximum. It is called orbital. For example, this is the nucleus. So according to Bohr's model, the electron revolving around the nucleus in circular paths. So, but according to quantum mechanical model, the finding probability of electron is here maximum, it is called orbital. 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 This is about the quantum mechanical model.